Close your eyes, imagine. You are 6 years old, gazing up at the night sky. Stars like diamonds scattered on black velvet fill you with wonder. That was me, mesmerized by the cosmos, yearning to touch the stars. That yearning, that curiosity, is the first spark in building a spaceship. It's the dream that fuels the fire of innovation. But dreams need structure, blueprints. Turning a childlike awe into a complex spaceship demands more than just looking up. It requires a mission, a clear defined purpose, a destination, Before the first bolt is tightened, before the first line of code is written, we need a goal. What will this spaceship achieve? Will it ferry astronauts to Mars? Will it probe the icy moons of Jupiter? Or will it travel beyond our solar system, a lonely sentinel searching for life? The mission defines everything. It dictates the ship's design. It determines the technology needed. A mission to Mars requires different considerations than a voyage to a distant star system. Distance, time, and the unforgiving environment of space all play a role. The mission is our North Star, guiding every engineering decision we make. Building a spaceship is not a solo act. It's an orchestra, a grand symphony where every note and every instrument plays a crucial role. A symphony of engineering disciplines working in perfect harmony, each contributing their unique expertise to create something extraordinary. Mechanical engineers design the physical structure, the very skeleton of the spacecraft. They ensure the ship can withstand the stresses of launch and the harsh conditions of space, conducting rigorous tests to guarantee its durability. Electrical engineers create the nervous system of the vessel, meticulously designing the circuits and wiring that will power the spacecraft. They are the architects of power distribution, communication, and navigation systems, ensuring that every component receives the energy it needs, and that the spacecraft can communicate with Earth. Propulsion engineers, the rocket scientists of our childhood dreams, develop the engines that will propel us beyond Earth's grasp, turning fuel into the thrust that will carry us to the stars. And let's not forget the unsung heroes, the software engineers, the magicians behind the scenes. They write the code that breathes life into the spaceship, enabling it to operate autonomously millions of miles from home. Their algorithms and software ensure that the spacecraft can navigate, make decisions, and perform complex tasks without human intervention, making the dream of space exploration a reality. Propulsion is the heartbeat of a spaceship. It's the force that shatters the chains of gravity, propelling us to explore the cosmos. But space is vast, and traditional chemical rockets, though powerful, are limited by their fuel efficiency. We need groundbreaking propulsion systems. Imagine ion propulsion using electrically charged particles to reach incredible speeds, or even more futuristic like fusion propulsion, harnessing the power of the stars themselves. The challenges are immense, but the rewards, the ability to reach distant stars within a human lifetime, make it a challenge worth conquering. The future is ours to seize. A spaceship is more than just a vehicle. It's a sanctuary, a haven, and a lifeline all rolled into one. It's a home away from home. Within its walls, astronauts find comfort and a sense of belonging amidst the extraordinary. And for long-duration missions, creating a nurturing environment is essential. The spaceship must be a place where astronauts can live, work, and flourish. Life support systems must provide fresh air, clean water, and ensure that every breath taken is as pure as the first. They must also regulate temperature and pressure, creating a stable and comfortable environment despite the harsh conditions outside. We're talking about creating a self-sustaining ecosystem, a miniature Earth within the confines of the spaceship. Perhaps using hydroponics to grow food, ensuring that astronauts have fresh produce even millions of miles from home, and recycling waste products to conserve resources, turning what was once discarded into something valuable again. It's about mimicking the delicate balance of Earth's biosphere, replicating the intricate systems that sustain life on our planet, but within the confines of a metal hull journeying through the cosmos. The challenges are significant, requiring constant care and innovation, but the goal to create a self-sufficient sanctuary for humans in the vastness of space is a testament to our resilience. It's a dream that nurtures hope and pushes the boundaries of what we believe is possible. And as we continue to explore and innovate, we bring that dream closer to reality, one mission at a time. The journey is long, but the rewards are beyond measure. Crafting a spaceship demands materials that are both ultra-light and exceptionally robust. These materials must endure extreme temperatures, relentless radiation, and the ceaseless impact of micrometeoroids. We're exploring advanced alloys, high-performance composites, and even self-healing materials. Innovations that redefine the limits of material science. These materials will shield our explorers from the harsh realities of space. This is where the forefront of material science shines. Innovation at the atomic scale is key. We're building the foundation for humanity's future in the cosmos. Before we entrust human lives to a spaceship, it must prove its mettle. Rigorous testing is paramount. Engineers meticulously inspect every inch of the spacecraft, ensuring that no detail is overlooked. Every system, every component, must be pushed to its absolute limits. This means subjecting the spaceship to conditions far harsher than it would ever face in reality. We employ computer simulations to recreate the stresses of launch, the vacuum of space, and the intense pressures of space travel. These simulations are vital in identifying potential weaknesses. The searing heat of atmospheric re-entry is one of the most critical phases. Our simulations ensure that the spaceship can endure these extreme temperatures without compromising its structural integrity. But simulations can only take us so far. They provide a theoretical framework, but real-world testing is indispensable. Eventually, we must test in the real world. Unmanned test flights are conducted to push the boundaries, gather invaluable data, and refine designs. These flights are crucial in transitioning from theory to practice. It's a meticulous process, fraught with challenges. Engineers must troubleshoot issues that arise, often working tirelessly to ensure that every problem is addressed. But it's a process that ensures the safety and reliability of our spaceships. Every safety check, every inspection, is a step towards ensuring that the spacecraft is ready for its mission. It's about mitigating risk and ensuring mission success. The ultimate goal is to create a spacecraft that can safely carry humans to the stars and bring them back home. Building a spaceship is a monumental triumph. It's a testament to human brilliance, unity, and our boundless quest for discovery. But it's more than just constructing a machine. It's about shattering the limits of possibility. It's about securing a radiant future beyond our home planet. It's about igniting the dreams of future generations. It's about turning that childhood wonder into reality. The challenges are immense, but the rewards are boundless. Building a spaceship is not just about exploring the cosmos. It's about exploring the depths of our potential. It's about realizing the extraordinary heights humanity can reach.